Tetracycline and doxycycline are part of a class of broad-spectrum antibiotics known as tetracycline antibiotics. All antibiotics in this class of medications are derived from the same basic 4-hydrocarbon ring structure. Each medication, however, is slightly different in terms of exact ring structure, recommended uses, pharmacokinetics, and documented bacterial resistance. Doctors prescribe both of these medications for many of the same infections, but each medication has been proven more effective than the other in certain applications. The primary difference between tetracycline and doxycycline lies in the pharmacokinetics of each medication. Pharmacokinetics is simply how the body responds to or acts on certain drugs. This includes how the body distributes the drug, metabolizes it, and eventually eliminates it. To illustrate, tetracycline becomes metabolically concentrated in different body tissues than doxycycline. Doxycycline, for example, reaches the highest metabolic concentration in the eyes, whereas tetracycline concentrates primarily in body fluids. Since tetracycline and doxycycline concentrate in different tissues, one medication might be better at fighting infections in a particular area of the body than another medication. Such differences account for both similar and varying clinical or recommended uses. Bacterial infections such as chlamydia, Lyme disease, and anthrax benefit from treatment with either tetracycline or doxycycline. As a prophylactic, or prevention against the spread of contagious bacterial infections like malaria and bubonic plague, doxycycline is typically more effective. Certain travelers are often prescribed doxycycline prior to traveling to areas known for malaria infections. Drug administration recommendations, such as taking with or without food, water, dairy products, and other precautions, are directly related to pharmacokinetics. Administration precautions illustrate another difference between tetracycline and doxycycline. Specifically, antibiotics are known to bind with food and minerals such as magnesium, calcium, and iron. Accordingly, patients are often advised to avoid combining certain foods or supplements with antibiotics to encourage better absorption. Patients are typically advised not to take tetracycline with food, dairy, iron supplements, or antacids. Alternatively, patients taking doxycycline are permitted to take the medication with food, as it does not bind to proteins in food as readily. Precautions such as avoiding iron or calcium supplements, dairy products, or antacids remain the same for both medications. In terms of discovery and use, tetracycline was introduced before doxycycline. First derived from the Streptomyces or ovitions bacteria, tetracycline is considered a naturally occurring compound. By contrast, doxycycline is considered a semi-synthetic antibiotic. Researchers, in response to increasing resistance of certain bacteria to antibiotics, synthesized specific changes in the ring structure of other tetracycline antibiotics to develop doxycycline. Comparing tetracycline and doxycycline, doxycycline has shown to be more effective against resistant strains of certain bacterial infections.